Okay, looks like chat's art streaming might be up and working. We'll see how that goes. So let's just play this one again. Software tools and the blacksmiths of tomorrow. Coding is more of an art than a science, and judging by the above, I could improve my art. So this set of videos is going to be about software tools, programming, having fun on computers in general. It's not a deep dive in anything, so it should be watchable by literally anybody. It sort of should be fine there. You don't need to know anything in particular. You can follow along with some of the web stuff, and hopefully it'll allow people to get some idea what goes on when someone says they code or write programs or etc. So no knowledge is expected to be required. So hopefully this will allow a perspective that's a little bit is based on 45 years worth of experience as a software engineer and 50 plus doing as a electronics hobbyist. So on the main screen, what I'm showing is a simple web page that I wrote and have been updating recently. And what it does basically, it emulates the let's see if I can demonstrate this. So these are Littlebits modules. They just snap together magnetically. They have basically power and one data line. Very simple modules. There's a synthesizer kit which comes with lots of different bits and pieces. So just if I can make it do something. So here we have a sequencer. And as you can see, the sequencer changing these LEDs. Think about being magnetic. You can't put two outputs together. It sort of repels. And that was what I was trying to get out of this on the web page is basically the fact that you can connect and disconnect modules. When they're disconnected, they stop working generally. There's a power on, followed by a chain of modules. And that they only use a very simple way of signaling between them, which is basically just a simple single connect wire, which is basically an analog voltage. And it has limited to 5 volts. So that's what this is what I'm trying to show and use as the inspiration. So here on the screen is the web page. Web 2 this is my development page, just the regular web page, just web, not web 2. This is like the sort of more the production. Sorry, I try to update this only periodically when I got a significant update. So we'll just go back to the development version. So let's just show. So we have a power on. Oops. So we have a power on bit. We can basically click on a bit or module, and we can then drag it around the screen. We can flip it horizontally. I mean, just so it's in a vertical position, and we can delete it. Or you can come over here and we can put it back. put one back, just like that. So these things, say they sort of snap together on their own. That's what I'm trying to emulate here. Just like that. There we go. So I have quite a few different modules. The Littlebits original modules have coded snaps, which are the end pieces, which would have the magnetic connectors in. And so I've done something similar here. So, for instance, we can take, say, something simple like a dimmer, which is basically a variable, a volume control type thing. So we can turn that on. We can then go to an output, grab a bar graph, and now we can sort of demonstrate. So imagine that the LED is going on and off. So one of the things I have done on this one is to one of the input formats is basically based on the sequencer, Littlebits sequencer. So there you go. It's now providing different values, and we can change the knobs values, how fast it's going. We can also make it basically go continuously. So what the gate does is it allows the it basically provides 100% is just continuous output. 50% means it's the value, and then goes down to 0 for the rest of the other half of the cycle. The way the Littlebits modules work is that they're using the single data wire in several different ways, sort of logical ways. So I have a synthesizer kit, and so the oscillator, if the input goes to 0, it shuts the oscillator off, it mutes it. Otherwise it provides what the note value is going to be. And so what I've done here is that on the sequencer output, I'm using the 0 value as also as a mute. So that's why it goes things. So this is a simple indicator. I've got more interesting ones. I have a simple line graph. So you can see how the values are changing over time. We can make them change faster. So, interesting little patterns we can do here. So this one, duty cycle, what is it? It says it's 100. It doesn't look like 100 to me. It's going to 0. Okay. That's my... oh, well, it's not 0, it's going to 30. 0 is 0. Yeah, it's not 0, it's just me. So we have this, and we can, so we could, for instance, now we can go to the kit of sound pieces. We can grab an oscillator, and we go back and grab a speaker. A bit loud, turn it down a bit. So we have the speaker, and we can change the volume. If we power it off, stops. So we expect we can go back and change the gate. Yeah, that's sort of annoyingly clicky. Now, one thing I did, I made it so that you can use the computer keyboard. So if you hit home, for instance, it highlights the first entry here, and then using the bottom row of letters, Z, X, C, V, etc., you can use those as like C, D, E, F on a music keyboard, and then Q, W, E, R is the octave above, so I can play do that, or so I can use the computer keyboard to program the sequencer. So we can change. We can get rid of that momentarily. We don't need the off at the moment. We can go grab basic input. We can have a sequencer with 16 steps. So we can program this one to do something like now we have a speaker. We also have an this is so the yellow ones are, notice they're square, and I made the original ones pointy. So these repel each other, not compatible, just like the bits are. So you can't link one of those. That's again using that model of pieces. So we can take the we can put this instead. So we now have a oscilloscope. One thing we can do here is we can change it to say triangle. So we can use this to demonstrate different types of sound. We can change this to sort of. Now we can change it to square wave. So we can drag the bits around. Now I've programmed it so that there's always going to be at least one bit on the screen. It won't let you scroll it off completely. It limits that. And one thing I did add was a map. So this is what I call a map. So basically, it shows you where the bits are. So for instance, if you scroll it off to the side here, you can draw power on over here. So now we can scroll it even further. So there's always a bit, but all the other bits are way off the screen here. And therefore, if you wanted to know where they were, the map helps you to show which one is available. And if you click on something here, it shows up a red dot. So for instance, we can click on the map itself. You see this little dot here. We can watch things drive around. Maybe we go. We have we can have lots of little functionality, things like that. So we have here the so we have there the audio, and this. So the grab those. So we have both the input voltage equivalent. So for instance, if I want to make it microtonal, I can stick in a dimmer. So 128 would be an semitone to note. I'll show you what happens. So we can do that, we can play with that. Obviously we could do something similar with so many of these modules have two inputs, which is basically the left and the top, and we can connect things to those instead. Drop this one down here. We'll need a power on, of course. Now, the oscillator has multiple things you can modulate. So you have frequency modulation, gain, which is volume, and the waveform. So, for instance, we can go from sine wave, triangle, saw to square. So that's sort of simple thing you can do because it's software has a version. In hardware, it'd be it's not difficult to do that in hardware, but it doesn't mix because obviously the oscillator does one thing at a time. Let's go and play with set it to gain. It sort of doesn't completely mute it, that was on purpose. And obviously we can use its frequency. Now, one thing we can do is just drag everything down here. So we go to basic wire, grab a corner. We can make it more horizontal instead. So basically, I think it's value of every step of 2 in the number here is a semitone, something like that. do that. We can play with, we can do simple things. We can grab a simple counter. And you see it just counts up. So we can obviously run that through the we have no modulation. Little. Now this counter's not configurable directly, so we can replace that with the one of several things. So one of the things I have in the MIDI kit is I have a MIDI clock, generate clock signal, and in MIDI you need to have, to configure MIDI action, what you normally have to do is grab a MIDI group object. And this allows you to select which MIDI input you want to use. So we'll use the circuit. I don't know why the clock. Okay, so the clock doesn't need a channel. It's not channel based. It does have tempo. So what we'll do, so if we select this again, we can see that the tempo is set to 120, and that's because we have the circuit set to MIDI clock. Just borrow that moment. So the MIDI clock on the circuit is set to 120. So what I can do is show. So this is the if we switch down to something else. I don't know. 80. I think that's 80. Switch back. And then I should have left it on there. So so tempo is now 80. So you can see the MIDI clock coming out of the circuit is currently being selected through using the MIDI group object. So we could change it to, say, the launch key. I don't know if the launch key is generating anything at the moment. And clockwise. Go back to the circuit, because at least I know that's working. So what I've done is the MIDI speed at which this goes up is based on the MIDI clock frequency. So if I up it to something harder, it goes faster, as you can imagine. And if I slow the MIDI clock down, it goes down. And what I've done is it uses the rate at which this goes up is based on the MIDI clock. So we just drop this back over here. So we have that's using MIDI to control a simple piece, using a dimmer to adjust the modulation depth. We can use an analog inverter so it goes down instead of coming up. disconnect it from the thing. So this is currently not being driven through the MIDI. It's using its own internal counter based on the web browser's time. But what I did do was grab where I programmed up the sequencer. What it does is the step the sequencer is currently outputting is based on the value on the input. So as the input goes from 0, this is number 0, up to 255. So I think there's 16 of them. So it's 16, every 16 value of 16, it goes up to the next step. So what I can do here is I can actually control I can drive the sequencer and select which step in the sequencer on the input. So that was, because I did that, I can then take, say, the MIDI clock-based sequence voltage source, and then use the MIDI clock to set the playback speed. So this has changed, so let's double refresh. It's around 120. So that's the timing is based on the computer versus the MIDI clock and the JavaScript processing, etc. So this will change a little bit occasionally. And again, I can now use a similar trick. If I invert the signal, you can see that the sequencer now runs backwards. So we can play with the sequencer. Obviously we can go and grab another sequencer, and we can use that sequencer and the MIDI clock. Now the voltage goes up based on 16 subdivisions, and so this one being only 4 knobs requires four subdivisions per. So I started to think about how to handle that over here. I don't think that's implemented yet. Why we need to make that implement so that would switch this up to a same clock. So it's currently basically a clock divider at the moment. But otherwise we can now pick which of the steps are going to be listened to. So there we go. So we go faster with the original. So there we have a sequencer controlling the order of the other sequencer. Yes, we can do that. So this is flexibility you get with some software emulating some hardware. So we could do the same thing in the hardware. I don't think the modules currently program that way. They have slightly different default options. So for instance, the sequencers, they only have a 4-bit sequencer. This switch here selects between internal clock, and this is the speed, or pulses coming in from the input. So I didn't want to, no, I didn't emulate that part. I did this device. What else is going on? So let's get rid of the, we don't need the graph. I mean, it's nice to have, we don't need it. We don't need, well, we'll leave that there for now. So apart from the oscillator, what should we do? Just drop, and we'll use that. Go back this, whoops. So again, if you drag the snap, it does that. If you drag the bit, it drags the mesh of bits that it's connected to. Yes, the audio path coming out of here is separate from the data signal equivalent. So, but if it's zero, if you disconnect it, it stops the mic. The speaker knows that it should be muted, so effectively it mutes the speaker. So it's programmed into the speaker module. It's like when if you disconnect it, it stops working. So we have oscillator and our little catchy tune. So we can then, we have other sound modules. We have a standard filter. We play it, we have a filter module. Program that with a sequencer. I'm not sure that's working properly. I'll fix it later. It seems to be wasn't a resonance too high. So yeah, it's not perfect, but it gives you the ideas. Turn up the resonance. So we have, what else do we have? We also have, oops, missed. We have the filter, we also have a delay. So we have delay time. I think I got from like 0.1 to 5 seconds. And we got how much feedback to dry to full wet. A lot of feedback. So that's a delay, but it works fine. Likewise, you can do the modulation, could be the delay or the feedback, the depth. Maybe broke it. So at least I've got the knob here animating. I can do that with some of the other knobs. Make it so that the when you're modulating, it actually just updates the knob rather than being an additive or control. Okay, so what else do we do? We added a panner, and pan left and right. These are sort of pre-built. Some of these are panning. Of course, we can run it on sequencer. So when you click on a bit, a module, if you click on, no, it doesn't have anything. Oh, okay, that's fine. Let's click on this section up here. Is a form which allows you to configure what's going on. So not all controls have something, but it is one thing. Actually, the panner. I don't think it has it. Okay, it doesn't have anything. Now, the sort of programming aspect of this is that what you have here, this chain of objects, is converted into a sort of byte or type values, and where the on modules are called a bit 1, and basically what it does is that it has, for each of these chains, it has a value stored in an array. And so the on bit of the on object has configured which chain it's activating. So the first one activates chain 1, and that has these following bits. So this one activates chain 2, which has these 2 on it. So if I take a bit off the chain, see the program changed. So this one is not connected to the wire anymore. I can disconnect it as well. So You can see here that again it's changed again. So that's a simple way of pretending to do hardware style stuff. This has limitations because I've designed it so that inputs are, say, left and top, and outputs are bottom and right, where right and left are the priority ones. So you're limited on some topologies. Now, one thing you can do, of course, we have MIDI. So if you go over to the MIDI section, Action, we can configure a MIDI output object. We can say, again, use, say, the circuit. You probably won't be able to hear it. Okay, now I've got to think about this. I didn't practice this bit. So now we have the circuit. This is our output group selector, and we can go to the MIDI output and correct. We can have the CV is obviously for note data. This is note data, and so we can send that to the sequencer. So that's playing through the circuit speaker. Wrong window. Again, so we're using the MIDI clock from the circuit to generate an increasing value here, which selects which step. So we can do what we did before. Find where's the inverter? Is it in the house paid? No, I got rid of it, I think. Just go and grab the inverter. Now we're running the sequencer backwards. So this is MIDI output for now we'd also have, I know what I need to do. It's really funny. I gotta fix that. It should mute. Set that note off. So that's playing MIDI notes really fast. It's really stupid. And you can just, you know, it's just, you can just play around with these things. Now we can change the using the note out group. We can send it to a different channel, which picks obviously a different MIDI channel. So we can play, if you go to channel 10, we can at some point we can hit the percussion. I just got to work out how to. Not having a mute is annoying. So we should be able to use. There we go. Should be an all note off somewhere. We just changed the circuit thing. So So what we can do here, obviously, is we can program up a drum, a rhythm, I suppose. I think it's, oops, it means these. Click here, hit home. On the keyboard programming, we go back, backspace goes backwards, enter goes forwards, space hits zeros it enters 0. So again we got Z, go back, hit Z again, 3 drums in a row. So there we go, we can, I don't know what that one does. Doesn't do anything. Okay, so it's limited in this, what the drums do. Let's do that again. Back. So we can just get rid of those. Yep, get rid of that. So does that one do anything? Not obviously. So that'd be C, D, E, F, G, A. I got the first 4. Okay. Anyway, using a web page to driver drums, and we can just run it backwards just because we can. We can we can change the tempo. It's MIDI. Now the other thing we can do on MIDI, we instead of using note output, so let's just change, just remove that bit. So MIDI output, we can also use control codes, control values, channel controls. Tidy up a bit here. So let's just play with. So first thing we can do is we can program up, use the mixer. That's working good. Okay, let's pick it. So obviously we're just playing one of the stat built-ins on the. Let's get rid of the. Just tidy up a little bit here because it makes it a little bit easier. How are we doing on time? We're doing okay. So we have a MIDI CV. So the nice thing about this is I added a learn function. So by default we're using default output group, which we've set it to circuit. We'll set it to, if we wanted a different, we could set it, create another group. We can just have a new group. These effectively, these group objects are effectively editors, and you can have as many as you like. So we have the default output group, which is say set to we can set it to circuit. We can set this one to circuit too, as well. So that's channel 1. We can set this to channel, say channel 2. There we have channel 1 circuit, channel 2 circuit. What else do I have we could send it to? Not sure for output. This is, I don't think the keyboard hasn't, these two had, that doesn't have anything on it, because that's the MIDI over Ethernet. So the circuit's the only device that actually has any currently hooked in. I have to add a few more, like the grandmother or something. I could do that. So we can select here. We can select which of the groups we're going to use. But because we have we do have an input configured to use the circuit. What we can do is when we have a channel here, it has a learn button. So it defaults currently to MIDI control. You select here, or you can enter the value by hand, or you can use learn, just like you can with, and I can just twiddle a knob on the circuit and it will learn it. Oops, which one ran the wrong? And we're not learning for some reason. Why are we not learning? Well, maybe I broke the learn function. In is circuit on channel 1. Learn. Maybe because I wasn't in the synth mode. There we go. So I didn't have a synth selected. So the knobs. I'll just show you that. These knobs weren't assigned anything. So I've just learned this knob. That's knob 80 on that synthesizer. So I don't know what that does actually on the tune. So anyway, this is now controlling. Set to control that. So what we'll do is grab initially just use this. If I do that, switch cameras. You can see. Watch the LED at the top there. So I can change the LED up and down just by dragging and dropping. Oh, Okay. So one of the conveniences, though this is an output, you can chain them together. So for instance, I can grab another output. I can hit learn. Oops, that's mute. I can hit learn on that and turn another different knob. Synthetic. And it's going to be set to output group. Group. Okay. That's my mistake. Group 3. There we go. So that's that knob. So this one has 80, and this one has high pass filter. So currently they're both passing through this number here. So for instance, I can obviously have it so that when one goes up, the other goes down. Oh, you can't see what I'm doing. Hang on. So what I did was, this one has been used the learn button, so it's now looking on control 81, and this one's looking at control 80. So this knob here, just the value being sent, and the opposite values being sent to the other controls. So on the overhead, the two knobs to the two leftmost parameter knobs, they should change in different directions as I wiggle the bit back and forward. I need another screen. Let's see if I can drag this somewhere else. Drag it up there. Oh, I got it. There you go. See the. I can dim one out and dim up the other one. Oh, the video is 10 seconds behind, of course. So there we go. It's a flexible system, and I'll probably end the stream about now.